So we can start.
Okay, fine. Are there any persons present here? Let me just see that here. In okay, two people, two participants, but that means our own. But so from in the team, nobody is there. Okay. Now in team, nobody is there, and in what about in YouTube that you are seeing that YouTube channel? It will be recorded, and then they can see the recording. I can speak on without this one. Okay. Questions, etc. Anybody will ask, how will you answer that? You are seeing there. तुम्ही सही से ताते?
नाही. Excel question.
येथे question आहे. Excel sheetat नाही. अब ये new question नाही ना. I think that anybody has joined and that information. One person used to come always, but this time today he has not come. Na? Old man. Okay. Anyway, so what happens that now it is the third session, and we have already discussed many things. Okay, like about this one, industrial engineering and operations research. So in the first 30 lectures, we talked about industrial engineering. So we talked about basically the engineering, what is the definition of engineering, how engineering differs from science, technology. And then after that, we told about mechanical engineering. We told about electrical engineering. And we also talked about industrial engineering. Okay. So then we also talked about how the industrial engineering evolved. So we era-wise, first division of labor 1750 to 1850, then 1851 to 1930, then 31 to 1960, 61 to 2102 onwards, industry 4.0. And then we talked about operations research. Actually, if we see, the operations research became popular in 1931 to 1960. Okay, that era. And operations research, we have already covered 25 lectures, starting from 31 lecture to 55 operations research. And we talked about what are the key topics in operations research: optimization, simulation, giving theory, network analysis, all those type of things. So if we just go to this one, okay, this is lecture 2. We talked about production planning and control, okay, which I will not repeat. Okay, already we have discussed it in the previous classes. Then we had 2 lectures on product design. Then we had talked about job, batch and flow production method. Then work study, work sampling, inventory. Inventory is a part of operations research. In the last 5 lectures, we'll talk again in detail about inventory, but we can discuss that management aspects of inventory we had already discussed. Okay, so this was this one, that inventory minimization is the goal, and functions of the inventory, finished inventory, setup cost, and some mathematics was there. First of all, that graphically we can illustrate that a simple inventory model in which at one time we get Q quantity. So order quantity is Q, and this keeps on reducing, okay, from here to here, okay. So finally it becomes to 0, okay. So now again we order, and immediately the order comes. So if we see that, and then after that gradually it is consumed. So basically we assume that there is no lead time. Okay, that means as soon as you order, the same day you get the quantity. Okay, so therefore this model is there, and so on an average always you will be having Q by 2 inventory, because it starts from Q, it becomes 0, again it becomes Q, it becomes 0. So average inventory is always Q by 2. So holding cost will be proportional to that, and ordering cost will depend on the order. So based on that, you can obtain that mathematical relation. And it so happens that in this type of model, annual setup cost our ordering cost will be equal to annual holding cost, and you get some this type of relation that optimum inventory at a time which you should order is should be equal to under root 2ds by h, where d is the basically demand and then h is the basically the holding cost and s is a setup cost. Okay, so that means that if you have d, then you can find out that this one. Suppose demand is annual demand is known to you. So if demand increases, this will not that. And similarly, the setup cost is more. That means you should order more often. And each holding cost, if your holding cost is less, then that means you can afford to keep more inventory and therefore Q star will be more. So this was that type of this one. And in that, we also discussed about, okay, total, this one production cost. Yes, suppose you are producing something and then simultaneously it is getting consumed. So this is basically demand rate and production rate. So it is 1 minus d by p term will come. That type of thing also has been told, and this is about this one. So this we discussed about inventory time type thing, but we also discussed some extra things, particularly if the inventory is probabilistic. Okay, so for that purpose, and first we discussed quantity discount model also. Sometimes there is a discount. If you purchase a bigger lot, you may get a discount. So you have to do the study of all the cases. Okay, what happens that if inventory is between 1 to 99, then you have to pay 1,000 rupees. But if it is a quantity is 100 to 1499, then price per unit will be 998 only, like that. 1500 and above, it will be 996. So you have to obtain the total annual cost, and when you optimize, then annual product cost is also can be added, and for different cases you can do the analysis. This type of topic I told, and then we talked about probabilistic model and safety stock, that how you can do that by probability thing. Okay, so probabilistic models, that means suppose a reorder point means accepted demand during lead time plus safety stock. Okay, and we find out stock out cost also and this type of thing. So in that there is a very interesting that newspaper model. In fact, in the literature, it is famous by newsboy problem, newspaper problem, like that. These keywords you can give and you can get a lot of material on that. Newspaper problem is famous. So newspaper problem is like that. Say for example, newspaper seller sells 125 copies of a newspaper each day. He believes the sale of the newspaper is normally distributed with a standard deviation of 15 papers. He pays ₹3 for each paper and sells for ₹5. He is given a ₹1.5 credit for each unsold paper. That means if it is unsold, then he can give back to that person, means maybe news publisher, and publisher will pay 1.5 this one rupees. He wants to determine how many papers he should order each day and the stock out risk for that quantity. So first we find out the cost of shortage. Cost of shortage will be sales price per unit minus cost per unit. Because I purchase a newspaper, suppose I am a newsboy, I purchased a newspaper and I am selling in 5 rupees. But my purchase cost is 3 rupees. So I am getting a profit of ₹2. So if I am having shortage of paper, that means I am losing 2 rupees per paper. Suppose suddenly somebody comes and asks, give me 10 papers. But I am not having any paper, so I say, no, all the papers have been sold. That means I lost 20 rupees, okay, because I had paper been with me, then I would have given 10 papers to that person. So 10 into 2 means 20 rupees I would have earned. That's why it is cost of shortage. And then another risk is that cost of overage. That means I could not sell the paper. So paper I purchased in rupees 3, but if I am not able to sell, then I will get back 1.5 rupee only. Is it not? Old paper will be sold by me in 1.5 rupee only, like unused paper. So this is 1.5, okay. So cost of overage is 1.5. Therefore, this ratio CS by CS plus C0, you can find out 2 divided by 2 plus 1.5. That means 0.571. Now what happens? You have to see Z value has to be evaluated. That yields a probability of 0.571. And using MS Excel command norms in V, 0.57 means corresponding Z value is 0.1789. So therefore, optimal stocking will be 125 plus 0.1789 into standard deviation. Standard deviation is 15. So that means 128 newspaper he has to purchase. So like that, you can find out that how this type of thing will work. And fixed period system is also like that. Okay, this one. So this anyway, inventory control techniques, ABC analysis, HML analysis, these type of descriptive things were also told, and this was the inventory management part. Okay. Then we told about supply chain fundamentals. We talked about TQM, total quality management. We talked about statistical quality. This one again, this is a mathematical portion. You can take interest in this. You can revise this application of statistics in this one. So this is very important that you have to say application of statistics. First, it is very simple things how you present the data in the form of pie chart, bar chart, etc. That everybody should know. Then we are telling about inferential statistics, sampling distribution, sampling error. We told about very important theorem, that is central limit theorem. Central limit theorem I am telling again because many people do not know, but it forms the basis of control charts, etc. and in many things comes. So what is that? It states that when the size of the sample increases and becomes sufficiently large, the distribution of the sample means tends to normal distribution. Okay, that means I may have any type of distribution. Suppose I have uniform distribution, that in the range of 0 to 10, you give me many numbers. Maybe you give 5,000 numbers. Now I take making small random samples. That means randomly between 0 to 10, I take only some quantity and 10 quantity and make average. So that average will become normal distribution. Okay. Even though the individual thing is not normally distribution, but new average will come normal distribution. Here we must take one thing in our notice, that the theorem is equally valid for both normal and strongly non-normal. So I said, even if you have non-uniform type of, if you have uniform distribution also, then also it will tend. So we can say even if the population distribution is strongly non-normal, its sampling distribution of means tends to normal distribution for large sample size. So we have seen that the sample mean is distributed normally with mean M, the mean of the population, which is an unbiased estimator. It can be shown that the standard deviation of the sample means called standard error. So we just call error. That means what is the error in the measurement of this one is standard error and deviation, almost the same thing. The standard deviation of the sample mean is called standard error, and that will be equal to sigma by under root m. Okay, so sigma may be standard this one. So what happens that if you keep on increasing the sample size, then averaging out effect is there. That means things get averaged out, and therefore this will become under root n. Okay, that type of thing. So that means accuracy will improve. Then important thing I told about hypothesis testing, such type of things with the help of student T distribution or Z distribution you can do. Like suppose cow's milk is protein is this, buffalo's milk many data. Then you say that okay, one mean is this, other mean is this. What is there that difference is significant or not? Depending and it is dependent on the standard deviation also. This type of questions you can answer, okay? And then we make cause and effect analysis many times we do this program. Pareto chart, okay? That means cumulative, this one is scatter diagram, trend analysis, control charts. So what is the basic concept of the control chart? If I am taking the measurements of some quantity in the industry, like I am turning some shaft, and then I am taking the only final diameter. So that final diameter may be distributed as per any this one, but what we take, when we take the measurement, let us say instead of one measurement, daily I take 5 measurement, random type of thing. And that 5 measurement and I take the average. I plot that average. Next day I take another average. So we keep seeing that whether that any time it goes out of the limit or not. If it goes out of the limit, then we say control action we take. So that means we have set some limit type of thing, and this is how that we take the corrective action. So this is the concept of the control chart. Okay, so control chart, suppose usually we will have control limit within plus minus 3 sigma. That means about 99.7 3% data will fall in that. So we make the control chart. We represent it like this: upper control limit, lower control limit, and we do like that. Okay. So this is process capability is defined as upper specification limit minus lower specification limit divided by 6 sigma, where sigma is the deviation, standard deviation. Okay, so this also we discussed, and this one will be having okay, another one mathematical thing comes here. Acceptance sampling. Acceptance sampling is a probability based technique. Okay, that means you have some lot, and in that there are defective, but you random way you take some, and then after that you see that whether the number of defective is increasing or not. So like I can have run like this, we take n is equal to 1000, n is equal small n is equal to 60. Okay, so total lot is 1000, but I will not do the inspection of 1000 pieces, otherwise it will take too much time. So we will take that 60 samples and we will put say acceptance number 3. That means in 60, if I get say maximum 3 defective, then I can accept that. Beyond that, I reject it. And let us say that the lot is having 0.01 defective fraction. That means fractional defective is 0.01. So in 1000, basically 10 pieces are defective. Suppose it is. So the question is that if I make this type of spreadsheet, then what is the probability that I will be selecting a lot even if the defective is more? Okay. So such type of things are answered. Okay, such type of things you find out basically the probability, and you use Poisson distribution or binomial distribution. We do that type of thing. So this type of thing. We also talked about consumer risk and supplier. That means purchasers, consumer risk and suppliers risk. Okay. So if we say that. That means I am just explaining. You can again revisit those lectures, but consumers and producers risk, supplier. So consumer risk means that suppose you make any sampling plan. Let us say you and me agree on certain thing that I will be inspecting only 100, and in 100 pieces I will tolerate 3 defects. If more than 3 defects are there, then maybe I will cancel whole lot. So since it is probability based, then there is everybody is taking some risk. Okay, that means consumer also has some chance that more than his expectation, more defective pieces can come beyond his expectation. Similarly, producer also has risk because sometimes producers' good lots may also be rejected because by chance, because of the probability thing that this happened, that that good lot was this one rejected, maybe by chance. Okay, because we earlier we decided that out of 1,000 pieces, maybe 10 pieces defective is okay. But it so happened that you were bad luck that all 10 pieces came in the, means there were not even 10 defective pieces. There were about 7 defective pieces, but 7 defective pieces by chance have come in the sample. Then you naturally it will be rejected. So that will be basically consumers. That means it will be suppliers, production persons, producers risk. Okay. So this type of thing is there, and that we discussed. We also discussed the double sampling plan, which is sequential, that suppose we have n is equal to 600. So we take n1 is equal to 30. Just we test 30 only, and we accept that C1 is equal to 1. If 0 or 1 defective is there, we accept this. But if there are 2 defective found, then we take that, then we take further that 45 other things we inspected. And then in that we say that in the new sample, maximum there can be total, altogether there can be 3 defective. Okay, acceptance number of the 2 samples combined together. So that means suppose take a first sample of 30 items from a lot of 600 and inspect it. Then you accept the lot on the basis of first sample. If it contains 0 or 1 defective, no problem, you take it, because out in 30 items you took as a sample, you found that maximum there is 1 defective. Okay, or there is no defective, then no problem, you pass. But suppose that by chance the defective is more, reject the sample if it contains more than 3 defectives. Suppose the first lot itself is containing more than 3 defectives, 4 defectives have come, then naturally it should be rejected. But by chance that suppose it has this one 2 defective, then you can take a risk. Okay, then you can say I will inspect 45 other this one, and if 1 defective comes, then it is okay. Or if suppose by chance you got 3 defective in the first sample itself, then you can inspect again this one, again that 45 pieces, but then there should not be any defective. So like that, this method is there. Okay, and acceptance sampling. So we kept on doing that. We went to then we have a lot of descriptive things that you can actually. We may have small questions on that. Control chart, I told. Control chart, how we control that method. Mostly it is table-based type of thing that we have talked. 6 sigma we told that basically very stringent. That means defects are something like 6 sigma. And then Taguchi's concept of loss function, that as you deviate from the target, you will loss increases, and 6 sigma is basically, that is this one, that means 6 at 3 sigma, it is 67,000 defects. But in 6 sigma, so this is this one, so it is much less, that about 3.4 defects per million. That type of thing I have shown. 6 sigma is this one. 6 sigma was developed by Bill Smith, and this is the sigma. So this is defect violation of 3 sigma. Manufacturing company purchase operate at 3, which translates into approximately 67,000 defects per million, while service company processes are often 1 to 2 sigma level. 1 to 2 sigma level means these many defects per million. Okay, the area under the curve of the normal distribution represents this one, and this corresponds to 3.4 defect rate per million opportunities. That means if you have something 6 sigma, suppose if flight is running at some airlines at 6 sigma, that means when 1 million, flights have taken place, 1 million time you have traveled, then only some is big or small price will be only 3.4 times, okay, out of 1 million means 10 lakh, okay. So that means it is very, very rare type of chance, okay. Then there is some Six Sigma methodology, and I told about ISO and OSA also from American Standard Occupational Safety and Health Administration. So this also we have told. Then we had another mathematical type of thing that was forecasting. No? Okay. Let me see anybody is there or not. Any question? If there is any question, we can take any question. I think here. Okay. Oh no, here in team there is nobody. Okay, forecasting. So forecasting is mathematical thing. Moving average method, very simple techniques. But then we also have exponential smoothing model, and we also have got this one, that forecast, this one, regression method, okay. So here you just fit straight line. So forecasting was also done. So forecasting, then scheduling, okay. Scheduling is again little bit mathematical type thing. Scheduling, okay, yes, yeah, scheduling, okay. Jobs of scheduling, that how should I schedule my jobs, in what I have 4 jobs to be done, but in what manner I should do the jobs, so that there is this one. It depends on your idea. That means you don't want to be late, you want to maintain due date, you want to be more efficient. So there is different type of metric. That type of thing was also told, okay. Scheduling, and scheduling, in the scheduling 2 job thing also, that if there are 2 machines, and sequencing in jobs on 2 machines, okay, that in that sequence, that A takes 2 hours and on machine 1, and 5 hours in machine 2. Similarly, B takes 6 hours. So in what way? So there is a Johnson's rule, that there is a heuristic, that suppose you see the shortest time is 5, so you put it here, and then you put it A first here, because A takes shortest time. Shortest time is 5. Job A and E are machine 2. So how your job A is already assigned, and assigned job E from first in the sequence, like that. So here job with the shortest time is 2 in machine 1, hence it is processed last, okay. So and next the shortest time is 3, or the machine 2 process it last. This is processed first, okay. Next the shortest time is 4, then it is this one. So here there is a mistake, that hence it is processed first. Actually the job with the shortest pass will be processed first, okay. If the smallest, find this smallest processing time on machine 1 and machine 2. If the smallest value is in machine 1, process that job first. If the smallest value is in the machine 2, process that job last, okay. And assignment problem, this is also basically, it is part of linear programming only, but we have other heuristic. That means there are, say, 3 product and 3 printers. You have to assign them properly, okay. So that means this is also, we discussed assignment model also, very simple. Then line balance, we told about break-even things. Industry 4 point, industry 5 point, mostly descriptive type material, big data, machine learning, IoT, and smart factory. Now we will discuss a little bit about the operations research part. So here we discussed about this one, linear programming, okay. Operations research, linear programming. I think we covered up to transportation model in the last class, did not? Last interaction, did we talk up to that? Transportation, okay. And we take, how do we do optimality test, okay. That means you have to transport 5 quantity, this one, suppose from plant 1 to market 1 and 2. Okay. Then CPM. Okay. Now we can discuss about CPM. Okay. Critical path method. Critical path method, we will make that how to do a job effectively, that suppose one to do activity A and activity B, it can be done in parallel, but activity B cannot start unless activity A is complete, and B should also be complete. So D A to B. Okay, so that's what. So this is a dummy activity. Here we make a dummy activity to just show that. Okay, suppose D can start only B is complete. This is indicated this, but if I join A here, then it will be same node. That's why we put a dummy activity, and then C can be done. And then we find out that how much backward pass and forward pass method, and then we find out that how much time it will take. Okay, so this we have already discussed. And CPM solution. Okay, this is finding critical path. Critical path means where we have to pay attention. Suppose we make the network diagram, then we find out the latest pass and the earliest pass, and then after that we find out the critical activities, and this is about that one. So critical path is one thing, and then we talked about the float also. Float means in critical path, float will be 0. Float of any activity 0. That means you cannot delay, but there are many other activities where you have some chances. Okay, that means total duration of the activity is only 5 hours, but you may have your level 7 hours. So 2 hours in the float. But it has also up to type 3 float, means freely you can use 2 hours, you can delay. But the other thing is that little bit restricted. That means you cannot have free, but if you delay it by 2 hours, then remaining thing also gets delayed by the same amount or something like that. So this is basically the float, means lag time. And this part also we have discussed already in detail. Those lectures are there. So naturally I should not do that. And in terms of the Taha books terminology, that we say that those activities which are in which there is some activities have to be red flagged. That means there may be float, but you have to red flag that, because if you delay it, then other things, that if free float is equal to total float, then activity can be scheduled anywhere within the span. Earliest occurrence of event I, latest occurrence of event J, in that you can schedule this one. But if free float is less than total float, then the start of the activity can be delayed by no more than the free float. Okay, free float is free to you. That means you can always use that relative to its earliest start time without causing schedule conflict. Any delay larger than free float must be accompanied by the corresponding delay of all the activities immediately succeeding it. Okay, so this is called red flagging rule. Okay, this is the thing that we have discussed about that. And part is the probabilistic thing. Okay, that means it is just like CPM. You can make that like CPM, but you have basically, first of all, you make the estimate of this thing. Somebody will do three time estimates. That means he will do most likely estimate, and then he will do that pessimistic estimate, and he will also give you optimistic estimate, and divided by 6. So TP plus 4TM plus T0 by 6. So that is this one. And variance is TP minus T0 divided by 6. Pessimistic estimate minus optimistic estimate divided by 6 square, and then compute the expected time. So like that you can calculate. You can calculate the variance of different activities. Then total variance on the critical path is the whatever activity you sum them. So that means project variance will be sigma p square. That means sigma variances of activities on critical path. Okay. So standard deviation wise, it is under root of that. So suppose there is a activity project variance will be how much? Okay. Variance in these activities is this much. You add that and standard deviation will be square of that. And then you can say that if you know the standard deviation, then you can say due date minus expected date of completion divided by sigma p. You can find out the z value. So z value has been found, and based on the z value, then you can find out the probability that whether the project will be complete or not. This is what that you do, that in that basically part 3 thing. And then project crashing. Crashing doesn't mean that any negative thing. Project crashing doesn't mean that crashing of the project, that project will be dead. That is not the idea. It is not aircraft crash. Aircraft crash means aircraft is gone. Project crash doesn't mean that. Project crash means project will be made faster. So that means English meaning is a little different. Crash the project means make the project fast. So some activities can be crashed. That means like we do a crash course. Okay. So by employing more persons for that activity, you finish it fast by putting more resources. That is called project crashing. So here also you can do some mathematical analysis that if you want to crash, that means normally it will take 10 days, but you can you want to finish it in 5 days in Tatkal or whatever is that thing. So you can put some extra money, but whether that money will be worth it, that you have to decide based on the other factors. Then we discussed about giving theory. Okay, giving theory was that about this one. Giving theory is a branch that suppose you go to purchase some ticket in railway station and you are standing, how much time you have to wait. Everywhere there is a queue. Nowadays, even you do many times online booking, but when you go for security check, you have to stand in the queue. Then why do we study that? So to decide that how many counters I should open. You see, you might have seen that in the airport, there are some X-ray machines, but how many X-ray machines should be put together? Unnecessarily, I cannot take 10 X-ray machines most of the time. It will be idle, and I cannot take 2 lists also because then excessive queue will be there. So you have to decide such type of things. That is why you are studying queuing model. Okay, and in that I hope told a lot of theory there, and you most of the time we say arrival is according to exponential one, where it is fx is equal to lambda e minus lambda x. This is the probability density function, and Poisson this one. So this type of thing also we did, and then we have done about giving theory. I generally up to in most of the mechanical engineers only study up to this much in BTech, that they will find out the probability of no arrivals during a period of time is E minus lambda T, where lambda is the arrival rate of lambda customers per unit time. Okay, this is the probability that there will be n arrivals during a period of time. P and T is lambda T to the power n E minus lambda n. And then general Poisson giving model, utilization of a facility. Very simple question. Sometimes you can say, if you know the arrival rate, you know the service rate, then you can say, okay, arrival rate divided by service rate is the utilization of the facility. Okay, suppose service rate is this one, so it is this one. So arrival rate, if arrival rate is same as the service rate, then it is 100% utilized. But most of the time you will not do that, because then unnecessarily that customer may feel get a lot of waiting time. So therefore service rate is always more than the arrival rate. So suppose my arrival rate, I have estimate that on an average 5 persons will come in 1 hour. So I have capacity that I can service 10 in 1 hour. So my utilization will be 0.5. That means I will not fully utilizing that thing. That much I have to be aware about that. And these are the some formula, that giving formula, and particularly general single server model. These are this one length of the the Q and system, that is rho divided by 1 minus rho. Okay, that means, and WQ waiting time is Q is equal to LQ by lambda. Okay, so these formulae are given nicely that you can actually see that, and you can apply these things, that most of the time questions on queuing theory are included in any competitive exam. And now here queuing theory. So we have given the example also. See, where the customers arrive at a counter randomly, usually 4 minutes on an average. Determine the probability that the inter-arrival time will be from 1 minute to 2 minutes. So if the service time distribution is also exponential, then what is that? So we have applied this. This is given example is there, and you also have formula. Okay, length is equal. Now length of the system is 3. That means service plus waiting together 3. And length of the queue is how much? 2.25. You may say that okay, one person is getting serviced, then 2.25 plus 1 should be 3.25. But why come that length of the system is only 3 and length of the queue you are telling 2.25? So answer is that it is not deterministic type of thing, it is probabilistic. Okay, so it will not be exactly that one person. So there the average comes out to be 3, and here it comes out to be 2.25 only. That means there is a difference of 0.75 depending on the utilization, because other time it is not utilized. Okay, that is why it is coming. If utilization was 100%, then you were right that 2.25 length of queue, then length of system will be 3 point this one, because system is always busy. But here the system is not busy. Sometimes it is idle also. So that is why the length of the system comes out to be 3 only. Okay, so that because all the time it is not serving, only 75% of the time it is serving. That's why it is coming like that. And then you have got then we also told about single server model. I said that, and then we give some formula, non-exponential service time distribution, by the way, that these expressions are there. And then we also told about optimum service level, and this one. And finally, we told a little bit about multi-server system also. Okay, that is multi-server model. Okay, so just we wrote the formula. We did not discuss too much on that. And then again, in the coming lectures, you will come to know about inventory. Okay, see those lectures again, and some this one, but we will also give some heuristic models like silver meal, etc. And then we will do that probabilistic example, probabilistic inventory. This will be discussed again, and we will be giving that this one. So let me just these lectures will be upcoming. Okay, just I am showing the glimpse. Part 4. That means that suppose everything is uncertain, that demand is not known with certainty, but probability density function is known. Then what to do that? Okay, so these type of things will be there. Okay, some type of mathematics is basic things is there. And finally that we discussed about that about inventory model, and this one, and assignment. Okay, now this is this much. Now a little bit time is there, we can discuss some assignment. Okay, assignment is there. You have kept assignment. A PPT is okay. So let us go to back side, and we have assignments. Okay, so we have already that you have given assignment solutions, and up to assignment 6 has been released. Assignment 7
has been
up to 8 has been published. Okay, up to 8 assignment. So let us revise, because in exam many questions will come from assignment. As per the new pattern, we will be giving many questions from the assignment. So it is worth seeing that solution of assignment. You can see again I don't think that there will be any problem for anybody, because all the questions are, descriptive type, and we have given in the solution in somewhat detail more than what was asked. Some extra thing like product life cycle we have done. So this is first course assignment. There is no problem. Second solution is also mostly descriptive. That means symbol, etc. Some question can come. Transportation symbol is this. Storage symbol is this. Inspection symbol is this. Then confidence, but some statistic questions are there. Confidence level 190%, that means Z value is 1.645. 95% means 1.96. 99%, 2.56. 99.9%, that means 3.291. Okay, these are the type of this one. Out of 1,000 observation, a worker was found working for 600 times. So some Z values I have given for 95% confidence level. The upper bound of the proportion of the time worker works is, the worker works 600 by 1,000 means 0.6 times. Okay, that means 0.6 times he is working, 0.4 times he is not working. That is the plain answer. But what is the based on the confidence interval? We find that Z is equal to 1.96. So we find out the standard error. That is under root P1 minus P. That means 0.6 is the mean value. 1 minus 1.6 divided by 1,000. That comes out to be this much. And then we margin of error we calculate by multiplying by Z. And we say 0.0303. So that means this much error can be there. Plus minus both. But since I have to find out upper bound, therefore I have done plus. If I have to find out lower bound, then I have to do minus. Okay, so this type of thing is there. So standard error. So that's what type of thing we are asking, that standard error is the maximum when proportion is 0.5. Okay, this is, I think it is based on that formula. This formula is very important, and this is what this one work sampling was introduced by DIXIT, and this is yes, and some descriptive type economic order quantity, some numerical EOQ is equal to under 2ds by this one, and this is about that, and then about the daily lead time, and about this one. So this is an internet of thing. Okay, some descriptive type questions. Now here, let us say assignment number 3 solution. Again, I discussed that here solution 3, it is about mostly quality, so descriptive type questions, no? And about general things. Like one question is about that, an example of inferential statistics is that. What is inferential? Average rainfall in Kanpur, that means it is some data. So no problem. Standard deviation, it is just information, nothing. Creating a histogram, inferential, descriptive. These are descriptive. Inferential means when you are making inference, you have say 10 values, and based on that you are doing prediction for 11th. Then it can be regression analysis. That means inferential. Or you might want to make some assess. You did some survey, and then you want to do prediction that which party will get more seats, BJP or Congress, like that. If you do this type of thing, then this becomes inferential statistics. In that category, hypothesis testing also comes. Then we are telling that important things is that what is a Poisson distribution? Poisson distribution means if you have got a large sample, but you know that small events are taking place, like in a city, sufficient population is there, but daily small amount of birth only takes place. Okay, maybe something like less than 1% or something. So in that case, you use the Poisson distribution. In our context, suppose a random sample of 50 items is chosen from the lot of 1,000 items. The lot contains 50 defective items. As per Poisson distribution, the probabilities of getting 0 and 1 defective items in the sample are how much? So suppose lot size is 1,000, sample size is 50. Then you find out percentage defective 50 by 1000, and 50 by 1000 comes out to be 5 by 100. That means 0.05, which is very small percentage. So you can apply the Poisson distribution. Probability of acceptance is expressed as PA is equal to N into P to the power C E minus NP divided by factorial 5. That means this is a formula. Probability that in such situation I will be getting C number of defectives is this much. N into P to the power C and E minus N into P by factorial C. So probability of getting 0 defective item is how much? PA 0, 50 into 0.05 to the power 0 divided by factorial 0, and this is this one. Factorial 0 is this one. So I am getting very small amount. Probability of one defective item is how much? 50 into 0.051 by factorial. This is this one. Okay. Probability of getting two defective item is what? That will also come. That if you put that type of thing, 50 into 0.0, probability of getting three defective item. So it is like that. It is not necessary that it will keep on increasing. It increases and then decreases also. So this is the formula, that this is equal to this one. So monotonically, yes, decreases with C when NP is less than 1. Okay, NP is suppose less than 1. Okay, in this case, NP is not less than 1.05. Okay, that means into 50. Okay, that means 50 into, so 2.5. Okay, 250 into 25. So this is 2.5. Okay, so this is equal to this one. So this situation is different. Okay, that means in 50 items, 1000 items, 50 defective. Okay, so in 50 items, but if it this one, then monotonically decrease with C if NP is smaller than this one. So this is what this one, that was percentage defective, and we did about that. Then about the Q chart, X chart, about the this one, and some descriptive type questions. Okay, and this type of problem in 6 sigma, a process produces 10,000 units. Each unit has 4 defect opportunities. If 80 defects are found, what is the defects per million opportunity? So total units are 10,000 and opportunities per is 4. So 10,000 into 4 and total defects is 80. So into this much, 1 million, so this becomes 2,000. Okay, so this is what that this type of thing. Similarly, we did assignment 4. In this, it was dependent on forecasting. It has been shown forecasting. That is, I think it is this one, and some questions will be some takes more time also, but some doesn't take much time. Assignment model also I did. Okay, assignment model may take more time, but this is equal to this, and then we will do assignment 5. Okay, assignment 5, this one, total time, it is about line balancing. Okay, about line balancing, and it is about PV ratio, break-even quantity. We also divided profit volume ratio, contribution divided by sales. Okay, so that type of thing, this also has been explained to you. And then after that, assignment 6, solution, reliability, and then data point with this one. Classification is a part of supervised learning. Procedure of the model, related to data in analytics. There are some definitions that we have used here. That suppose precision. How do we say precision? Precision means total positive, true positive divided by true positive plus false positive. That means I got some positive, some doctor detected. In 60 cases, he detected that there is a cancer on 60 patients. But out of that, 50 were collected. 50 people really had a cancer, but 10 just got the false positive. That means they were not having cancer, but doctor predicted. So 50 divided by 50 plus 10, that means this is 0.833, and this is what that option is. Okay, so this is precision. Accuracy is TP plus TN, 2 positive, 2 negative, and divided by total observation, 2 positive, 2 negative, false positive, false negative. Is it not? Everything together. So these type of definitions are there, and then IoT and cyber physical system difference and all those type of things, they have been told, and this is this one. And up to assignment 7 we have released 8. Okay, so assignment 7 is this, that which will be those 3 operations research, and we have basic solutions. Here there are big questions, but that we have said graphical method, and then we have done mostly the Taha book. We can do much guideline, and then assignment 8. So assignment 8, which has been given, is double. Okay, primal and double. How to make primal from double? This type of thing has been explained here. So all these type of things have been given. Okay, primal, double, and magnitude of the Lagrange multiplier. Okay, Lagrange multiplier is like a basically unit worth of resource. You can say it is a type of shadow price also. Okay, that type of thing is there, Lagrange multiplier. So solutions are given that. Is it simple thing? First problem itself tells, suppose a primal linear program problem has 15 decision variables and 10 constraints. Then its dual will have 10 decision variables and 15 constraints. Okay, so that is what that this can be this one done. Okay, so sometimes you can get an advantage of means which problem is easier to solve. Okay, suppose you have less number of constraints. Okay, then maybe you have less number of rows in this one table. You may have more variable, but you have less number of equations to solve. Okay, constraints. So you may get advantage, and sensitivity analysis also, that time also it helps. Okay, that type of thing we have showed, and primal problem. So I think that we have almost covered, and we have, I think our interaction time is also over, and in the team there are no questions. Is there any question you asked that? Is there any question in there? Or this one, I think no questions. No questions in YouTube. No questions. Okay, fine. So therefore it is okay, and then we can wind up this. Okay, we can wind up. Yes. Okay. So Lego is open. Can try CPU.